Okay, let's start ramping it up a little bit, especially when it comes to the functions that we're going to be integrating. So up until this point, all we've been integrating are baby polynomials. Something, x cubed over 2 plus 7x to the minus 1. Yeah? No, to the minus 2. Let's not deal with the minus 1 yet. We've been just dealing with baby polynomials like this. But obviously, just like the differentiation, life just don't work like that, okay? We have got a lot more things to worry about than just x squared and x cubed. So let's start off with this idea of the standard function, integrating standard functions. So what are standard functions? Well, they are essentially functions that you should be able to look at and immediately know the integral, which sounds crazy. But there are a couple of good reasons for this. And of course, in a couple of videos' time, I'll show you how to prove every single one of these. But for now, we're just going to treat them as standard and how we can use them. Let's look at the integral of sine x, for example. This is a standard function. This is one that you should just be able to look at and go, duh, I know what that is. But if you're pretty new to this, you might be looking at that and going, well, what? I don't know what the integral of sine x, are you crazy? Well, no. What you do know is how to differentiate things. You know, by this point, hopefully, how to differentiate sine and how to differentiate cos. And you know things like the derivative of cos is sine minus sine. It's not like bond. Sine minus, doesn't matter. The derivative of cos is minus sine. And because you know this, you can kind of work backwards. Because we know the derivative of cos is minus sine, then just by definition, we must know that the integral of minus sine is cos. Because that's how integration works. It's differentiation, but backwards. If I take the answer and I integrate it, I will end up with the start. So if the integral of minus sine x is cos, well, it would follow that the integral of just sine x is minus cos plus c. Don't forget plus c, I never have. Yet minus sine x, or sine x integrates to minus cos x, just by the knowledge that you have already from differentiation. And we can apply this to everything. We can apply this to the integral of e to the x. I don't know what went on there. Of e to the x dx. Why? Because we know that e to the x differentiates into itself. The derivative of e to the x is equal to e to the x. So going backwards, integrating it, the integral of ex must be e to the x plus c. Not going to catch me out. So just by our knowledge of differentiation, we can just look at a lot of functions and know what they integrate into. For example, cos. What do you think cos integrates into? Well, sine. Sine differentiates into cos, so cos integrates into sine. They go backwards, yeah? Back and forth. What about something like the integral of 1 over x dx? And the reason I bring this one up is, I kind of mentioned it earlier next to the minus 1 and I freaked out. Let's just see why for a second. Let's treat this like a polynomial and say, well, 1 over x is x to the minus 1. So let's do some polynomial integration. Let's do x to the minus 1. It's plus 1 to the power, so I get x to the 0, divide by the power, I've divided by 0. So it's not possible. Well, it doesn't look it when we do polynomial integration, but we may remember a certain fact that the derivative of ln x or log x is equal to 1 over x. So the integral of 1 over x, well, we can't do any of this because we're dividing by 0, so we have to use our knowledge of standard functions, our knowledge of differentials, and say this is actually equal to ln or log x plus c. Too hasty with that plus c. So just being able to use this idea of standard functions really, really helps us. And this is what we mean by standard functions. They can get a bit more complicated. For example, we should know the derivative of tan. So derivative of tan is sec squared. So if you ever see the integral of sec squared, we should immediately be thinking of tan as the answer, etc., etc. Now, as I said, I will be proving, the methods to doing some of these, not all of them. Some of them, like the integral of sine, the proof of it really is this idea of working backwards. So there's not really a proof here. Same with e to the x, same with 1 over x. They're all just standard functions. We don't need to prove them. A couple of them, like tan, we can prove and we will prove. And I have proven some of them in my shorts videos that not many of you lot watch, actually. People who watch the long videos tend to not watch the short videos. Fair enough. Just keep away from the brain rot. Fully respect it. But my point is that using standard functions is very, very useful, and it allows us to skip quite a few steps in having to prove things or trying to prove things from first principles.